In this video, I want to give you a quick overview of what we will be learning. Okay? We will be simplifying radicals, including not just square roots, but also cube roots, fourth roots, and even higher. So like you know how to do square root of 45, we're going to make sure you know how to do something like the cube root of a number, or even the fifth root of a number. Okay? It works a lot like it did for square roots. Okay? Another thing we're going to do is you already know how to simplify radicals that are square roots. We're going to be simplifying radicals with variables underneath the radical. Okay, so again, you know how to do the square root of 45. We're going to learn, well, what happens if we have something like the square root of 45, a to the third, b to the fourth. Okay, we'll also do it even when there's like a cube root. So you might have something like the cube root of a to the third, b to the fourth. Okay, well, and it works a lot like square roots, and you have a lot of knowledge that you can build on there. Okay. Another thing we're going to do is we're going to make the connection between radicals and rational exponents. For instance, when you had like the cube root of 32, that means the same thing as 32 to the 1/3 power. The denominator of the exponent and the index of the radical match. Okay. And so like when you're trying to evaluate the fifth root of 32, it means the same as 32 to the 1/5 power. So there is a button on the calculator that'll do the fifth root. You type in the 5, you hit a button that kind of looks like this, then you type in the 32. Or you could type in the 32 raised to the 1/5 power. Okay? So we'll talk just briefly about that, how to make the connection between radicals and rational exponents. Okay. All right, so there's a bunch of simplifying of radicals, even when there's variables. We're going to look at 2 applications of square roots. Okay. One of them is the Pythagorean Theorem. You may remember that from geometry. It said if you had a triangle that had a 90-degree angle, a right angle in it, it said that if you squared the 2 shorter sides, they're called the legs of the triangle, it would equal the square of the longer side. Okay. Right, and then the other formula is the distance formula. And it says that the distance of the line segment between 2 points can be found by using the formula d equals the square root of, and you subtract the x coordinates, subtract the y coordinates. They're each squared, and there's a plus sign in between. It's really just the Pythagorean theorem an application of the Pythagorean theorem, really. Okay. Both of those aren't too hard. Okay. After that, we're going to add, subtract, multiply, and divide radical expressions. Okay. And we'll learn that when you're adding and subtracting, let me change that. That looks like multiplying. When you're adding and subtracting, you need like radicals. Just like when you're adding and subtracting fractions, you need common denominators. Okay. And then we'll do our multiplying and dividing as well. Okay. All right, and then after we do the adding, subtracting, multiplying, and dividing of radical expressions, we're going to revisit solving radical equations. Okay. Some, like you've already done, things like this. Can't remember what it was. I was trying to remember that equation we did earlier. There it is. Okay, some like x equals, it was negative 3x minus 40. Actually, I think it was plus 40. You know, we just did that one. That was something you knew how to do already. And then we'll look at, well, how would you solve something if it were a cube root? Something like this equals to a number. How would you do that problem? Okay. So you're going to have a lot of knowledge to build on here, and we're just kind of filling in the gaps a little bit. Okay. So I'm going to stop this one, and then I'm going to start using the examples from the More on Radical Expressions and Equations sheet.